Hello and welcome to another video lesson with Mr. Roman. Today we're going to be going over the Quiz 4 Review 1. Really the directions are: determine if each pair of triangles are similar, and if so, state which theorem you used, and then find the value of x. So the three similarity theorems that we looked at so far are the angle-angle similarity theorem, which is AA, the SAS, which is side-angle-side, and then the SSS, which is side-side-side. So here we look and we see that we cannot use the side-side-side similarity theorem because we don't know the value of the third side of this triangle here. And so we also cannot use angle-angle here because we don't know enough about the interior angles here of the triangles. So our only other option is to check with SAS to see if these are similar triangles. So we would take the angle that we know is congruent there and take these two sides as SAS. So we're going to set up a ratio of 12 to 8 is equal to 9 to 6. And when you do that division there, you should get a value of 1.5 and for both of them. And so that means that they're similar. So we'd say similar by SAS. So that's the first part. And then we need to find the value of x. So then we're going to set up a separate ratio to find x. And I would probably set up the ratio of 9 to 6 is equal to 15 to x. And then use your cross product. So 9 times x equals 6 times 15. And then solve for x. And you'll get that x equals 10 in this case. Okay. Then number 2. So on number 2, we're going to look at these two triangles to see if they're similar. And here, we don't know anything about the angles, so we can't use the AA or the SAS theorem. So we have to use the side-side-side theorem. And we want to set up 3 different ratios to check to see if these are in fact proportional. So you'd want to do like 18 over 24 is equal to 21 over 28. So you have those 3 ratios, and those all come out to be here 0.75. So that means they're in fact similar. And then we can say that they are similar triangles by the SSS theorem. Number 3, we look at the triangle and we see that we don't know anything about the angles here, so we can't use the AA theorem or the SAS theorem. I'm sorry, I take that back. We don't know all the sides of the triangle. So here, this third side of this triangle, x, we don't know that, so we can't use the SSS theorem. But we could use the side-angle-side theorem and say that both triangles share the common angle of C. So we'd want to use the small triangle with the big triangle to set up our ratio here. So the ratio we can set up is 15 to 20 equals 27 over 36. So the two sides of the triangles, and then we're going to get that both of those ratios are in fact 0.75. So these are similar triangles based on SAS. And then once we know that they're similar, we want to find the value of x, so we'd set up the green proportion here and then do the cross product and find that x is going to be 28.8. 28.8 for x. In number 4, we look at the triangles, and we can see that since these are isosceles triangles, we know the base angles are going to be 75, 75, and 75, which then in fact makes them similar triangles based on the angle-angle similarity. And once we know that they're similar by AA, then we can say that the ratio of 6 to 11 is equal to x over 4, and solving for x, you get 7.3 repeating. On number 5, we know nothing about the angles on this triangle, so we can't use AA or SAS. So we're forced to use the SSS theorem, and here's the proportion that you would want to set up. And when you do those, you're going to get 1.3 repeating here, 1.3 repeating here, and then here you get 1.25, which then immediately tells you that these are not similar triangles. Then on number 6, again here, we don't know anything about the angles of the triangles. We do know that these are going to be congruent to each other and that these will be congruent to each other. But we don't know what the relationship is between the green and the blue. And so we can't really use any angle similarity theorems here. So we're forced to use, again, the SSS theorem. And we would set up the red proportion here. And we would find that each of those are proportional. And so they have a proportion of 1.5, or I'm sorry, ratio of 1.5. So then we would say, yes, these are similar by the SSS theorem. In number 7, we look and we know only 2 of the sides of one of the triangles. So the SSS theorem is out, and that would be this triangle here. And we know a common angle, though, between 72 here and 72 there. So, and we don't know any more angles, so the AA is out. But now we can try and use SAS. However, when we look to try and connect the angle here with 2 sides that are known, we only have 3 sides that are known. And the 4th side here, the one we would need to use, we don't know. So we cannot actually use SAS here. So we're going to just go ahead and say that they're not similar triangles, based on the fact that mainly we don't have enough information to say they are similar triangles. On number 8, we look at the angles, finding here that we would say that using the triangle sum theorem is 31 degrees there, and this is going to be 47 degrees. And immediately we notice that these are not going to be similar triangles based on the AA similarity theorem. So we would just simply say not similar triangles. On number 9, we don't know enough of the sides of the triangle to use the SSS theorem. But we do know that two angles are congruent. So we have one set of congruent angles here, and then another set of congruent angles here, which means that we can use the AA similarity theorem. So that, yes, they are similar by the AA theorem. And then we would set up the proportion in blue there to solve for x, and we would get that x equals 13.3 repeating. On number 10, we do not know the 3rd side of the triangle here, so we're unable to use the SSS theorem. And we do not know if the lines here and here are in fact parallel, so we can't say anything about the corresponding angles here and here, or even here and here. So we don't know enough information about angle-angle similarity, and we don't know the 3rd side over here, the whole side of the triangle, to determine the SAS, because we could technically use the B angle to be congruent for both triangles, but we don't know the value of x to make those sides corresponding with the angle. So this we would have to just say are not similar. Okay, number 11. Again, we don't know enough information to use the SSS theorem, but we can say with our triangle sum theorem that this is 55 degrees and this is going to be 77 degrees. So using the angle-angle similarity theorem, these would be similar triangles. Now, we set up the red proportion to solve for x, and you have to be careful here because you want to make sure you're using the corresponding parts. So the 48 to the 77, that is going to be this side here, which, I'm sorry, DE, is 15 in your diagram. I did not have that on there. So DE would match up with AB, and then we would say the 48 to 55 here would match up with the 48 to 55 here. So that's why we can write that proportion. And x is 12.13 repeating. In number 12, we don't know enough information about the angles to use the AA theorem or the SAS, but we do know all the sides of the triangle, so we can in fact use SSS here. And we need to kind of break this apart, so the strategy here would be to take this triangle and to flip it. So after you flip the triangle, you're going to get this kind of figure, and I would try and put that back into the figure. And then you're going to see that the whole side there from P to S is going to be 12, and then P to R is going to be 8. And then you have the smaller triangle here broken up into pieces. And then you set up your 3 proportions to see if all the sides are similar or proportional. And they are. They all come out to have a value of 2. So then you would say they are similar by the SSS theorem. Then on number 13, here we're not going to use the SSS because we don't know all the sides of the triangle. And the AA AA theorem is out because we don't know all the angles, but we do know that this angle is congruent to this angle by vertical angles. So we can try and use the SAS theorem by saying these two sides match up here, and these two sides match up here. So we need to write our proportion, and we say 8 over 4 is equal to 7 over 3.5. That should be 3.5. And so these both have a ratio of 2, so we would say yes, they are similar, and that is by the SAS theorem. This concludes our review for quiz number 4, part 1, and I will see you all in class on Monday.